Okay. I'm not Glenn Orton. My name is Fachreddin Tabataba-Vakili. Glenn Orton had to go to the hospital because of an inflamed pancreas. Anyway, but I'm going to talk to you about the observations we've made with the JunoCam instrument on the Juno spacecraft. The JunoCam instrument is a public outreach program, basically, and all our data is being put out into the open just as soon as we get it. And amateur scientists and amateur astronomers can take our pre-processed data and do further image processing to produce these very amazing pictures that we see here. And this one set of image here, it's a sequence of images of showing Juno flying further south. We can see the North Equatorial Belt, the South Equatorial Belt, the South Tropical Zone, the South Tropical Belt, and the South Tropical Belt. And as we go further down and down, we see there's more and more turbulent regions happening with rising latitude. And here there's a very turbulent band happening here. So I'm going to zoom into this region here, which is really amazing. And this is how it looks. This feature is called the STB Ghost, and it's a very large cyclonic region which has been happening, which we know of, which exists for about a few years now. And note that there's a huge circulation going around it, and there's like tiny little pop-up clouds that we can see with the detail of having JunoCam go that close to Jupiter and taking these tiny little detailed photographs. This picture shows a turbulent region up here, and there's it's a cyclonic turbulent region, and it's interesting that we can see like little orange hazes collecting above the cyclonic regions. But please keep in mind that all the colors in these pictures are enhanced. Basically, the color, each amateur processes the images in their own way, and the color differences are explained by them using a different kind of color palette. Yes. So here we see a little more detail of the detailed features of Jupiter. Down here we see cyclones at the North Pole, cyclonic vortices. Up here there's a very, very turbulent region, and it's amazing how detailed we can see the cloud patterns and everything. And here, I think this may be flipped, but this is the east part of the STB Ghost that I showed before. And again, the detail of the little white clouds is amazing. This is a combination of pictures from our observations of the poles. And on the poles, we've Juno is the first spacecraft who can actually measure the poles because of its polar orbit. And what we can see here was not expected at all. There's a structure of vortices oriented about the pole. which is almost constant in time. It wobbles around a bit, but it has stayed in this shape and with these longitudes for about a year of measurement now. And this is the South Pole, and the circumpolar cyclones here have a pentagonal structure, and on the North Pole there's an octagonal structure happening. This part we couldn't see with our instrument because it's winter on the northern hemisphere right now, and it's always dark. Oh. Right, and here we see movement of one of these circumpolar cyclones. I'm sorry about the resolution. This is not in 4K, but you can basically see how it rotates. Right, this is another really cool image of a beautiful storm. Actually, in this picture, those small little pixels here are actually the smallest thing we've ever measured on Jupiter. One pixel on this picture is roughly 6 kilometers across, which does not sound that tiny, but for Jupiter it is. What we think these little clouds are actually little vertical clouds of possibly fresh material coming up. And we can see some shadows here in these fronts, which actually gives us roughly the idea that they might be as high as they are wide, so roughly 6 to 10 kilometers high as well. Yeah. You mean from a chemical point of view? Not really. And again, the color is very enhanced to make out the differences better. But no, it's possible that it's fresher clouds that are higher up, but it's not clear at this point. Right. And here we see a series of images going over the Great Red Spot. Of course, the Great Red Spot, we've known about it for over 400 years now, but with JunoCam, we've been able to get up very close and see these tiny little details and the swirls around in the center of it as well. And here, now we should see a video crossing the Great Red Spot and what our spacecraft kind of sees while going over the red spot. And here we see small cloud features. Oh, no, I changed. We basically see a little wave structure here if you look closely enough. And also there's tiny cyclonic or anticyclonic parts going around here in the center of the Great Red Spot, and it's a little white spot. I'm not sure. It could be noise. Yes, I think that it looks like noise. Yeah, so we're not using the full resolution of the screen, so every little pixel gets blown up here. And now we're moving farther away from the red spot and looking behind us to still kind of look at it. Any questions while the video's going? Oh, how fast. I think it crosses from the South Pole to the North Pole in a few hours. So it's pretty fast, and especially once you get closer to the equator, it gets even faster. And now we're moving away. And we see other detail of belts and zones happening and very turbulent features. Right. Next one. And again, our amateurs, they do an amazing job with making the pictures look like they are. But some of them take a more artistic license. And this picture basically shows you that the Great Red Spot is so large that it could swallow the Earth whole. And let's see. Here we have another amazing storm. This is north of the Great Red Spot. And this is also an anticyclone like the Great Red Spot. And it has a variable mixture of red and white color. And I think we've known about this storm for at least 24 years, and it's still going. We not only see weather on Jupiter, but also other features. This is the shadow of a moon of Jupiter. This is the shadow of Almathea. And now we see a video that basically what JunoCam sees while crossing the doing the close approach along Jupiter. And all of this takes roughly, I think, 2 to 3 hours to complete, maybe 4. And it's coming closer and closer to the equator. It sees awesome banded structures and details. And the closer it gets to the equator, the closer it physically gets to the atmosphere. And at the equator, we can see amazing detail. Right, and also this video is also made by an amateur, just putting together the different pictures that we've seen. And here again, there's more pop-up clouds happening. And these features here, where there's a row of pop-up clouds, that may actually be similar to a storm front on Earth. Yeah, and now we're getting further away from the equator again and going towards the South Pole, I think. Yeah. And yeah, I'll just leave the video up. Thanks.